Okay, good afternoon, everybody. I guess some of you were in the previous storage session and have just returned to this one. I only noticed when I restarted it that it's actually in the same stream, so I don't know whether we could have left it running or not, but anyway. Okay, usual admin point. If you've got any questions to ask, then please ask them in the Zoom chat window. We'll get to them at the end of the session. We'll have a wrap-up session. When we've got through the questions in the chat window, then I'll unmute your microphone so that if you have further questions or follow-up, then you can do that using voice. Okay, so we've still got a few people joining, but I guess it's time to get started. Let me first of all thank Beth Peterson for agreeing to speak to us today. I guess the topic is one which is pretty active. When zHyperlink was first announced, it was clear that what we were seeing was the early stages of it, something that had a lot of promise. But there'll be more to come, and I guess Beth is going to tell us about some of the more to come and some of the extensions to the environments in which zHyperlink is supported. So Beth, thank you very much, and over to you.
All right, great. Thank you, Nigel. I'm Beth Peterson. I'm a senior technical staff member for IBM here in Tucson, Arizona, and I come to you from Tucson, Arizona. And so this really, I appreciate that my session is to AZ, since AZ is the postal code for Arizona. I'll go ahead and get started. We've got some interesting things to cover today. And as Nigel mentioned, we definitely start with sort of an initial building block approach to any new technology that we release. So we started out with reads, moved into writes, move from simplex volumes to metro mirror volumes. And as I'll discuss here, we now have global mirror support, and that's going to be a big advantage really moving forward for our customers as they need to do remote replication. So I'm going to talk just a little bit about what zHyperlink is, kind of the evolution of it. This was a joint project that was done between IBM Storage, myself, a team of other architects and developers, along with the Z side of the house, firmware, various software layers, as well as the actual hardware aspect of it. When we first started to do the analysis around what it was that we wanted to do, we were very focused on it was going to be a paradigm shift. It had to really be optimized for incredibly low latency at all steps. And when we looked at even how to go about doing it, I think when I was first approached with it, I was like, no, I don't think we can do that. There's no way to do that. And there wasn't, unless you really looked at it from the ground up and rebuilt it. So that the code path was really optimized on both ends to really be mindful that this is a synchronous operation, that the mainframe CPU will spin on waiting for this transaction to occur, this operation to occur, and really made us focus on delivering incredibly low latency and just really looking at how to do that completely differently. We see that the asynchronous nature of how we do our normal code paths with FICON or zHPF allows us to optimize for the channel and do a disconnect to allow the channel to continue on with other activities. But there's a lot of overhead, and we'll talk about that a little bit. So we see. When we first started to develop it, we were looking at, how was that impact going to be based on the hardware at the time. And you do get benefit from power boundaries between Power 8 and Power 9 and so forth. So with the Power 8 DSAK generation, we see that the zHyperlink operations are about 5 times faster than the high performance Ficon. And we see with the power boundary with P9 and the 8950 that we get a 4x improvement with Hyperlink over high performance Ficon. So despite the fact that there are great benefits on a power boundary, with our performance, you still are looking at the technology and the ground up sort of redesign of this transaction as really providing the lowest latency in the market today. We see that it's got such a great impact on DB2 transactions that you can really feel. And I think that's important to note, that the console operator, the operator, the end user, they can feel the difference that Hyperlink transactions bring to the table. And as we expanded, the types of replication that we could support with Metro Mirror, Hyper Swap can be used with that. So it's a great integrated replication kind of a option. And we'll talk more about how Global Mirror plays into that as well. I will also say, when I was first involved with the project, one of the things people were talking about was how important latency is and what could occur because of lower latency, or what couldn't occur because of higher latency. And they were really talking about things like online shopping, or a transaction where you're there with your credit card, trying to swipe. And that I understood. That makes a lot of sense, especially with the pandemic. Big internet shopper at this point. I can appreciate that. If I'm getting the indicator that's saying this transaction is waiting, I might go and do something else. So I get cart abandonment, but I didn't really understand the fraud part of it. And so I was looking for examples, and I came across one where they were talking about fraud detection and cart abandonment. And it was a bank card company, and they were talking about their credit card authorization system and how latency was king. And if their storage latency was above a certain clip level, their fraud and abandonment numbers went way up. And what happens was they couldn't effectively run the transaction with all the end-to-end checking, the fraud detection, and all the rest of that fast enough to keep the user engaged in the transaction. Or you wouldn't be able to run the fraud detection and then have a problem, later on. And so they saw that they would have enough lost revenue due to fraud or abandonment if their latency was too high, that that they could buy a new storage farm in about an hour. That was the real world example that I came across. So I think that's kind of a key thing to keep in mind, is that low latency has a real business benefit. When we were first looking at doing this paradigm shift, we modeled it. We were inspired by the coupling facility for the mainframe. So the mainframe is able to, and as you can tell, this chart is a older chart with the Z14 reference. This was really, we could see that the Z14 was able to offload aspects of their work to the coupling facility and do that in a synchronous way, and do that with point-to-point PCIe. And yet, if they were to need to come to storage instead, they had these much higher response times. And we noticed as well that when we not noticed, we analyzed it to see what was going on in that code path that was all of this overhead, not just to the processing of the IO itself, but if we had to go asynchronous, all of the things that you had to do to then get back on thread, context switching and cache pollution, and all the latches and locks and things that have to go onto it. So it's really not just that the IO takes this long, it's all that other end-to-end mechanisms that are absolutely required to do the processing. And so we also saw that, kind of what we are, the workload kind of things that we're looking at, you're going to see that we, at least in the DSAK, are very conscious of having things in our cache. So a cache hit is something that we have all kinds of caching algorithms under the covers to provide. So you're going to see that typically you're going to have about 80% cache hit ratios on random reads, and you're going to have 100% cache hits on writes. Is kind of what we were looking at when we were thinking about what can we do from a synchronous I/O perspective. With the zHyperlink, with that point-to-point PCIe connectivity, with all of the code optimizations, our goal was to have IOs that would complete in around 20 microseconds. So really, you know, order of magnitude smaller than the type of transaction times we were seeing with standard FICON, high performance FICON IO. And that was really kind of how it came about. I think it's important to talk a little bit more about how do we do it. And I always like to talk about, you know, it's more than that PCIe connectivity. It's more than the fact that it's, you know, point to point and there's a new interface around that. It is really about that optimization that was done from a storage perspective. I always like to think about it as go, no go. It isn't that you're going to wait for a little bit and then just not tell the mainframe you're waiting. It really is optimized from the ground up so that we don't spin on locks, we don't wait for resources. We have an entire different approach for us to understand, like, that resource is available now. This information is available now. And if it's not, it's no go. And that's okay. That can be redriven through the FICON interface. We are not looking at replacing FICON. We are looking at this as a compatible technology. And so I think that's a key thing to note. The Hyperlink Express is a direct connect short distance feature. And you know, we do that in conjunction with the you know, the FICON or the high performance FICON SAN infrastructure. We have a new card in the mainframe itself in the PCIe IO drawer, and that's going to have, you know, several ports available for that. It does not take a fan out slot like short distance coupling does. It's going to connect directly into the IO enclosure of the DSAK or the, you know, whether it's the 88 or the 89. It does not require a new host adapter card. And I think that's important. I know in some conversations with customers that can be something just to clarify. It does not replace any of those host adapters. It's in conjunction with that. There are some, you know, you can have a variety of number of connections based on your storage configuration, number of cores and CPUs and so forth. We also, you know, think it's important to know that it is retried on FICON or HPF if it's a no-go. And of course, there are other reasons why you need FICON. All of the other sorts of commands that are processed on FICON, whether that's all of the path validation or replication, things of that kind, also require FICON. We found that with the design that we were able to do, the applications above things like DB2 or Media Manager, they don't particularly need to make you know, any changes. Those changes are made within Media Manager and DB2 to optimize whether or not we're going to have that IO be through Hyperlink or be through high performance FICON. So we can see here, this is sort of a high level chart. I think this was on a prior power boundary as well. And this is looking at what the response times look like at a high level, as well as the not just for the individual IOs, but really what does that feel like from a transaction level. We can see the reduction of batch processing jobs by 50%. We can see that it's really it's leveraged well for OLTP. We find that there's an aspect of this where you're not going to necessarily take all of your IO and put it through Hyperlink. We're really looking at how to address the bottlenecks. So if you have a bottleneck where maybe you've got a bunch of IO that's running and it's running fairly quickly, but then it's waiting for something, that thing that is waiting for it to process. In this case, it's typically around the logging that you might do for DB2. That's really where your bottleneck is. So if you can optimize how you do your transactions, how you do your IO associated with where the bottleneck is, then it allows everything else to run that much faster. So you don't have to put all of the IO through Hyperlink to get these tremendous benefits. You just have to, remove some of those bottlenecks. Again, showing just the significant differences between Ficon and Hyperlink, looking at being able to remove those queuing delays in the CPU, being able to remove that cache pollution, being able to have the storage so fast as to be able to do those transactions within that microsecond type of time frame. So this chart needs a little explaining. So so one of the things that I think you have to look at is that all the way over on your right, you're going to see C1. C1 isn't just that little gray area. C1 is the time spent in DB2 and the time spent in the front end. And it's going to include CL2 and it's going to include CL3. So it includes that entire amount. CL2 is your time in the DB2 address space, and that's also going to include the part that's in blue, which is your CL3, the sync IO suspension time, all that locks and latches and suspension time, async read suspensions, those sorts of things. So you can see that, in the normal running of Ficon or high performance Ficon, where you're doing what would be to the end user a synchronous database read that's needed for a transaction. There might be multiple IOs per that transaction. We can see that these sorts of operations that have the 10 gig buffer pool, that we were able to have half the lapse time in this example. However, one of the things that is important to note is, even though you do get great benefit from Hyperlink, even in the case where more is cached higher up in the mainframe environment with the 70 gigabyte pools, you're still looking at a 23% reduction in elapsed time. So that, even though larger buffer pools are a better option for improving latency, more memory is better. Even with that, 10 versus 70, the zHyperlink adds that additional latency benefit. So that's something to keep in mind later on when we're talking about how to choose your Hyperlink eligible IO. we help you in IBM. We've got some tools that will help you with that analysis. But even with this kind of behavior, you can see that there is high value in the hyperlink. So as Nigel alluded to, we started out with a small offering and then built from there. We really do like to do a building block approach. And we move all of these technologies, all of this support forward. So initially on the 8880 series, with our release 831, and then moved through all of the releases, and now of course on the 8950 or 8910, we initially started out with read support, and just being able to do the hyperlink interface, all of those interactions, that protocol. And so that was initially supported with DB2 version 12. That support was rolled back for version 11. I used to do this chart in sort of the order things occurred, but it's at this point you can find it in these various places, so might as well just mention them all at the same time. So this was initially allowing for database reads. We also came out with the zBNA tool, which I'll talk about later on in the presentation. We also then extended that read support to VSAM. The majority of the record type data sets are supported, with the one caveat about NSR sequential. And then one of the other kind of neat features that I think is really helpful, especially hand in hand with the zBNA tool, is the granularity that you can use to tailor where you want to turn on zHyperlink with storage class policy, or if you want to just run a quick test, you can do the very SMS command to turn it on. Then we expanded our support even further in the DSAK and within software to be able to support the DB2 active log. That is our rights. That is another part of that bottleneck statement that I mentioned, where we can look at how to remove that bottleneck of those rights. That we're not necessarily doing it for all of your DB2 rights per se, but if you can focus on that logging, that really does have that benefit of removing bottlenecks, or really wherever the zBNA tool is able to identify good candidates that would be beneficial to you. And so that's supported in both storage and in software. We also have the changes where we've got the hyperlink ports in the IO Bay enclosure itself, and just to kind of show you sort of the layout of part of the 8K, and as well as to sort of reiterate that it does not replace the number of host adapters you have. It's separate hardware. And then to also highlight in this chart, depending on the configuration, the number of cores in that configuration will be the number of max hyperlink connections. We have you do them in pairs. And the reason for that is within the control unit, as part of the optimization, we have dedicated threads to perform the hyperlink operations. We don't want to only do hyperlink IO in the control unit. So this is part of how we control that and throttle that hyperlink IO just a bit, so as to not starve out the regular FICON IO or all of the other operations and tasks that we do within the control unit. Wanted to spend just a little bit of time on hyperlink rights with Global Mirror. And this is where I give my standard caveat that if I have not already, I will at some point in this presentation get tongue-tied. We have a lot of hyper. We've got the hyperlink where we can do the reads and the writes, but we also have hyperwrite. And hyperwrite is very important to our ability to do Metro Mirror with hyperlink, with the go no go paradigm. But hyperwrite itself is in a way another building block technology. We've had hyperwrite for several iterations before using hyperlink, and being able to do it with high performance Ficon. It is a way for software to handshake with the control unit to tell us that they're going to do software mirroring. And that can be really helpful for load balancing or performance. And so that was just a technology that we had available to us. And with having the software mirroring available and having software control the write to both the primary and the secondary, that takes away the wait time in the control unit that would normally be done for that synchronization, serialization of the writes from the primary to the secondary. So with hyperlink, right, hyperwrite, and hyperswap, you get performance and high availability. You're going to use hyperwrite to be able to do those replicated writes. They're going to complete at about the same time. It looks a lot like the kind of behavior you would get with simplex. And the hyperwrite, it does really improve your transactional response time by doing those write operations in parallel. That's really something we see with HPF and how it's been adopted with DB2 and IMS WADs and things of that kind. So separately, it's a great technology. And then in conjunction with hyperlink, it's very, very beneficial. It allowed us to do Metro Mirror. But of course, this chart, kind of a teaser chart. Oh, we don't do asynchronous replication yet. From a configuration perspective, with Metro Mirror, it's important to note that the PCIe optical cable point to point, it is, it's got some limits based on speed of light. So we do recommend that you keep your, whatever box you're going to connect to the mainframe with within 150 meters. So when you are talking about Metro Mirror, that means that you need to have your primary and your secondary within 150 meters. And so if you are in a situation where that's not viable from a Metro Mirror secondary perspective, that's okay. You can still get great benefit from your hyperlink reads. That's perfectly fine. Customers will run like that. They may do that by choice. They may do that as they adopt and start testing it. But you don't have to run both reads and writes if it doesn't make sense in your environment. And of course, we have hyperswap, and as we move into the discussion about global mirror, we now have this long distance asynchronous replication. So that gives you the best of all worlds, right? You get the performance, the high availability, and the disaster recovery. I think sometimes it gets lost in these presentations that it doesn't have to be 150 meters. That's sort of the max. It's definitely, you definitely would want to do a shorter distance. If you can do a shorter distance, choose the cable length that's the lowest, since distance adds latency. So I think those are key things. One of the things I really like is the DSAK 8910, which is our small form factor control unit, and you can get great synergy with the Z mainframe. So one of the things you can do is you can do the DS 8910 in a rackless system, which is integrated with the Z15 TO2 model, have that in that compatible rack. So now you've got kind of like this mini subsystem, and you can run hyperlink with that. So you get the smallest cable you can. And I just think that's such a clever idea for having that really low latency and incredibly short distances. All right, so I feel like I should have like a drum roll here, some kind of sound effect. This was a big deal to be able then to extend hyperlink writes 2 global mirror primaries. That really was challenging to do, especially in the go, no go paradigm, and looking at one, not affecting how long your hyperlink writes are taking. So you really don't want to then, add this replication, but remove some of that latency benefit. But by the same token, you don't want to impact your global mirror RPOs, how quickly you can form a consistency group, all of that. So really had a balancing act to make sure that we were, covering both bases. With being able to do global mirror, now if you've got much more of the whole picture for you, where you can have multiple regions, you can satisfy a lot of those regulatory kinds of requirements that you have, either governmental or based on your industry, or even just in how you like to do your testing. It's important to have not just the local copy, as we were able to provide with the Metro Mirror, but now expanding our technology to really satisfy how our customers run. So now you've got that best combination of performance, high availability, and disaster recovery. And again, making the point about hyperwrite. When you're looking at your Metro Mirror, it's not a factor for global mirror. That's separate. So again, it does help with write adoption. It does open up more use cases by having that global mirror support. We are able to do that, of course, for the DB2 logs. We find that so we found that with the the interactions with Hyperlink and Global Mirror, that again, from really both perspectives of write response time and Global Mirror consistency group formation or RPO time, you when you're doing Global Mirror, you have sort of this consistency group coordination time that's going to interact with Hyperlink. We've tuned that so that even with needing the dedicated resources for that consistency group forming, that we are able to still have 90% or better synchronous rate with the Hyperlink. There are small windows during consistency group formation where it's no go. And then in those time periods, we would have those operations done asynchronously with high performance FICON. And so we see that we are really able to tune it so that the vast majority of the operations are going to be synchronous. So we're going to get into now my favorite charts. Oh, no, not quite yet. Let me just tell you what the levels are before I get into my favorite chart. I got too excited there. So we are able now to open it up to be able to do hyperlink writes with Global Mirror. That allows for more MGM or multi-target Metro Mirror configurations. And of course, the standard caveat about hyperwrite. And it gave you a couple of the software levels as well as the DS8K level. So this is on our 89 series, so the 8950 or the 8910 with release 9.1. All right, now my favorite chart. So with this chart, it sort of shows the effect of this go, no go paradigm, the effect of making sure that everything is available to the control unit before we start to process the IO. We see that in blue is no mirroring or simplex, in green is Metro Mirror. In purple is global copy, and in gold is global mirror. So with global mirror, there was a very small impact to the response time for these 4K byte writes, but it is very, very small. And you can see they're really all pretty much flat, pretty much the same as the simplex rate. So that was very key. I think it's important to note that the high performance FICON chart shows in a way why hyperwrite is so key, with the green being the metro mirror. That is metro mirror without hyperwrite. So there is no software mirroring occurring with that. If software mirroring was occurring with the hyperwrite, then that green bar for high performance FICON would look more like the blue bar, which is simplex. And so you can see with high performance FICON, where there is more processing done on an IO to IO basis, rather than the paradigm switch of having the resources available before, you can see that there is an impact to your response time for your more asynchronous approaches. This chart shows the other side of the coin. So this chart shows what's happening when we are holding the consistency group formation rate steady. We're holding the throughput steady for FICON versus hyperlink writes. So we can see that you're getting a better overall average response time by putting the hyperwrite. I did it. See, I told you I would. The hyperlink writes into the picture. You can see this log emulation. It's not DB2. It's emulating DB2 writes. You can see how much better that throughput and response time is in comparison, with still being able to not impact your consistency group formation. I think that's just incredibly important, and you are seeing that 4x improvement in response time for those hyperlink writes. And this chart, a similar point, but with throwing in some reads, hyperlink reads, to again show that it's not impacting your overall system performance. Your throughput goes up because you're driving more I/O, but the key things with this chart is we are able to hold that consistency group formation time steady, and so you're not impacting either end. You're not impacting within any significant amount your latency for your writes themselves, nor are you impacting your global mirror. And then just a little bit back to that storage class granularity. You're able to do that with reads and write capability being separate. The way it works in the mainframe is that that class attribute is looked at on a IO by IO basis. So if you do change your SMS configuration with a new storage class definition, that will happen. That will take effect immediately. There are other options for that enablement, different granularities, or you could do that very SMS to kind of do a quick test if you want to. That's not persistent, whereas the storage class definitions are persistent. Those storage class ones are, they'll survive like the IPL. I would mention as well that by being able to do this fine grain control, you can really, pick what's important to you once the analysis is done about which data sets maybe you want to focus on. And that sort of leads into the next chart, which is, well, which data sets do I want to focus on? So we make it easy. We have the zBNA tool. It's something that IBM will provide. You could work with Washington Systems as well to have them help you with that. So it's definitely a very helpful tool to understand kind of what your behavior looks like from the mainframe. It's going to be used in a hyperlink perspective to identify your top data set candidates. It's going to give you a lot of information. It can be filtered on time or date. It'll actually estimate the benefit, and it'll generate some real-time reports. You may have already used this tool for the, looking at the benefits for EDC, or what it would cost to do encryption at the CPU level. You can download it. You can Google for it. Oops, I'm sorry, little wild there. Or you can play around with it yourself, or you can have IBM help you with that. This is another chart about what it would look like as far as some of the output, give you a little bit more information in a different style. You can see in this example where it's comparing the kind of massive improvements that you can see with the response rates with Hyperlink, with avoiding all of that, those wait times you might have had otherwise, where you're able to go ahead and just directly access those records in cache. This is another way of illustrating what the benefit is. And by having those reports like this one here, when I went back, you've kind of got your data set name and sort of the characteristics associated with it, even without having Hyperlink in your system. You can see what the benefit would be before you even buy. And then before we get into some of our real world examples, just one more chart on it to kind of highlight what's being decided, with those records, with that ZBNA tool, but also to talk about, you can see what that eligibility looks like and see if your business would benefit from it before you have to invest in it. And I think that's a great benefit for that tool. You can try before you buy for free. And even once you do have hyperlinks and you have them enabled, there are always times where you might have some synchronous IO need to be done in an asynchronous way with the high performance Vicon, depending on resources, depending on other aspects like that. And we have a variety of new link statistics specifically for Hyperlink that can help show sync versus async as well to gauge performance. So Hyperlink has been out for a bit now, and so customers are starting to look at how does it work, and does it work well for them? And so I'll walk you through a couple of examples with a few customers. This particular customer, they were on a Z14. They had, for storage, they had the 8888. They had Metro Mirror. They were running a Kix job that ran DB2. They were focused on 4K reads, and this was their test environment. So their feedback was that their transaction response time was reduced by 0.5 milliseconds. They saw a performance optimization of 28%. They found that 90% of the IO completed in 20 microseconds. I thought that was very interesting. And then for the IO that was outside of that 20 microseconds, 99% of it completed in 30 microseconds. So that's fantastic. And they did find that there was a small impact to their CPU time. I'll talk a little bit more about that on our last slide. It's not unexpected to have a small change in your CPU time, and a lot of it does depend on how things are set up, how is the test run, what is the overall activity. The expectation is that although the CPU is spinning, waiting for that synchronous IO to complete, it is ultimately going to be flat or a slight improvement, just because you've taken away all of that other CPU work that was unnecessary when you talk about reconnecting, when you talk about thread context switching and latching, locking, all of that kind of stuff. For the next example, this one was also in a test environment, Z14, the 8888, DB2. In this case, they had Hyperlink reads and writes, and they saw the following sorts of behaviors. So their average read response time using Hyperlink was 23 microseconds. Their average Hyperlink write response time was 29 microseconds. And they could do a comparison then between their high performance Ficon and their hyperlink. So with high performance Ficon, they saw that their average log write rate was 9.9 K per second. And with hyperlink, it was 16.5 K per second. That meant to them that they got a 79% reduction in the average database I/O delay time. They got an 80% reduction in the average active log write I/O time. And they saw that their active log write rate increased by 67%. So that was 20 megabytes per second to 33.4 megabytes per second. Whew, that's a lot of numbers. And they saw that their overall average DB2 elapsed time was reduced by 40%. So this was, they were running a, online transactional, set of processing. And this is the kind of stuff, these are the kinds of numbers that that mean that your customer or the operator is really going to feel the impact of that elapsed time. And then finally, another example, in this case, it's in production. We've got Z15, we've got the 8886 Metro Mirror DB2. They are running 4K reads. This customer, they saw in production, and really in the area where they were focused on, was a 20% reduction in the key claims batch processing times. That was what they were looking at. They saw an 8% reduction in response times for certain critical online transactions. And they saw a variety of improvements in some of their other transactions that they had out there. They did not see any downsides to the implementation, and they actually saw a slight reduction in the CPU times. They didn't have very much to do to implement it. They really just felt like they changed some SMS definitions and they turned it on. They didn't restrict usage. They just opened it up for the entire DB2 data sharing group. And so after all of that discussion around, oh, you can surgically turn it on, you don't have to. It really, they were able to just turn it on and go. And they got some really great results. I think it's really key to look at that particular real world example with CPU usage. We do expect the zHyperlink to be CPU neutral or have a slight increase for most customers. We see as well, it does have some dependency on the kind of mainframe. If you have a subcapacity machine, the CPU benefit is even higher because the number of instructions that would be executed in the time it takes to perform the hyperlink read, for instance, would be less than it would be on a full capacity machine. And of course, that CPU cost is the time that you're spinning. So we really do find, though, that those CPU benefits with that reduced front end path, not having to do the I/O interrupts, and having back end processing be eliminated is really not to be discounted. There, we don't expect there to be this massive trade-off. We actually expect there to be a benefit because you're not wasting your CPU's resources, doing all that overhead. So that concludes the majority. I will leave you with my final screen here to submit feedback. Again, it is a number near and dear to my heart, with it being to Arizona, to AZ. And so I really appreciate your time and attention. I think at this point, Nigel, if you want to, we could take questions, and I will I will continue to share if people have a slide that they want to talk about.
Okay, thank you very much indeed, Beth. I have a slight confession to make. My laptop fell over and decided to reboot about 10 minutes ago. So the contents of the chat window have now totally disappeared. So I know there were some questions in there.
Okay.
I know some of them were answered, but it's now a matter of complete mystery to me what they actually were. So let me see what I can do. Okay, I seem to have lost the ability to unmute people.
Let me see if I have the chat, Nigel. Okay, is there a max distance that zHyperlink will work over from Colin? Okay, Nigel, looks like you answered that. Okay, John made a mention about not being able to do, not being able to do the DB2 log benefits, but you could get some good benefits from the reads. Yeah, I think that's fair. The fair point that John has about the bottom left controller labeled site 2 can't be correct. It must be at the primary site following the 150 meter limitation. Yeah, I can go back and correct that. Oh, Nick Clayton, thank you, Nick. Real world benefits, yes. So I think Nick is highlighting the 20% reduction in batch jobs for users, favorite long running batch jobs, as well as 8 to 15% reduction in transaction times. And again, if you don't need to be doing the reads from the storage, then you're not going to get benefits. So that was part of that chart as far as it's talking about if you've got your larger buffer sizes within the your host. If you're not even coming to storage, you're not going to get any benefit from Hyperlink. It looks like Brett asked a question about the global mirror chart. And so Nick was able to clarify that site 2 is a GDPS term for the secondary and is a logical site 2, and having an incremental resync connection. Let's see. So Nick also clarified for us that if the global mirror primary failed, this would be used to restart GM from the surviving primary. Brett asked, essentially like MTIR for Cascade with Metro Mirror. Nick said yes. And I think we're caught up. If I summarize those correctly, if we have more questions, I can answer those as well if people are able to be unmuted, or to just put something in the chat and I will try and capture that for the group.
Everybody can unmute themselves if they wish at this stage.
Now my dog is in my room with me, so he's pretty quiet. He probably won't bark. Maybe he has a question. I don't know. Okay, let's see. It looks like Andy. Oh, you missed copper channel cables. Fair enough.
Okay, are there any further questions?
Okay, great. I'm not sure if my information is available or not, but if there are further questions, you can always send them to me. I am at kanga@us.ibm.com, and I would be happy to answer additional questions.
Okay, so thanks again, Beth. I'm just getting down off the high of having the Zoom session disappear on me whilst I was the chair, but never mind. I have to say I'm very impressed that it stayed up without catastrophe. If there are no further questions, then again, thanks very much to Beth, and I will end the session. Thank you.
Thank you, everyone.